Hello everyone. Today I am going to discuss limits. So today I am going to discuss what a concept and definition of a limit of algebraic function, trigonometric, exponential and logarithmic function will discuss today. So what is the concept of a definition of a limit? A limit is defined as a value that a function approaches the output for the given input value. So it is used to define integral, derivatives and continuity of the function. So we have a general formula here. Limit x tends to c f of x equal to x, where c is the maximum limit and x is the input and L will be the output and F indicates the type of functions we are operating. Next we have limits of algebraic function. It is the systematic process to know the value of variables in the algebraic expressions with the help of limits. Take one example based on this. What we have solve limit x tends to 1 with the value as the equation what we have x cube minus x square plus 1. So in this we should have to put a value as a 1 wherever we have a x. How much we have got? 1 cube minus 1 square plus 1. 1 cube means 1 minus 1 square means 1 plus 1. So 1 minus 1 will get cancelled. We'll get the answer as 1. Take a second example. Here also you just solve it for a limit x tends to 1 equal to x square plus 1 divided by x plus 100. Okay, so here also they have given a limit x tends to 1. So 1 means we should have to substitute wherever we have a x value, there we have to put a 1. If sometimes they will give x tends to 2, that time you should have to substitute 2 wherever you have a x. Now in this question we have 1. So substitute 1 as wherever you have a x. So after substituting, how much you will get? 1 plus 1 divided by 1 plus 100. Okay. So 1 plus 1 is nothing but 2 divided by 1 plus 100 is 101. So we can say it answer will be 2 divided by 101. What is a trigonometric function? It is the systematic process to know the value of trigonometric function with the help of limits. So this is the standard waveforms of the trigonometric functions we have. Based on this limit only, we have got this type of waveforms where we are using a general day by day. Okay, so sin x is we have a alternating, cos x we have a waveform, tan x, cosec x, sec x and cot x. We just differentiate all the waveforms here. So next what we have, limit of trigonometric functions. For the formulas what we have, that is sin x. If you are applying a limit x tends to a means wherever we have a sin x, you just put it a value. Last we have just solved the problems. Now similarly same here also we should have to put wherever we have a x. So sin a will get after applying a limit. So second one what we have, cos x. If you are applying a limit x tends to a, then the answer will be cos a. Then we have a tan x. After applying a limit x tends to a, you will get answer will be tan a. The a value will be ranging from any numericals value or any value you will get it. Take an example here. Evaluate limit x tends to 0 sin ax divided by bx. Here x tends to 0 you have. Okay. So multiply and divide the function by ax. You will get sin x tends to 0 sin ax divided by ax into ax divided by bx. So divide and multiply we have did here. Okay. So x get cancelled as ax by bx and you will get a by b only. Okay. Then this a by b constant you take it at outside and sin ax by ax is nothing but what? 1. So after applying a limit we'll get a 1. So after we'll get a by b into 1, then the final answer will get it as a by b. So next concept we have a exponential function. Okay, so the limit of an exponential function is equal to the limit of the exponent with the same base. It is called the same it is called the limit rule of an exponential function. We have one general formula, that is limit x tends to a b raised to f of x equal to b raised to limit x tends to a f of x. Take one example here. Limit x tends to 1 with the function of 3 raised to x plus 2. Here limit ranging from 1. So wherever you have a x, you just substitute a 1 value. So we'll get 3 raised to 1 plus 2. 1 plus 2 is nothing but what? 3 raised to 3. We'll get an answer as 27. Okay, as per exponential formula, we should have to take a base raised to power value. Okay, so from base value, what we have here as per the equation, 3 we have 3 raised to limit x tends to 1, then we have to take a power value, that is x plus 2. Then again here also you should substitute a 1 wherever you have a x. So we'll get 3 raised to 1 plus 2, then we'll get 3 raised to 3, then final answer will get a 27. We can say it by using a both formula, we'll get an answer as 27 only. Next we have a logarithmic function, where the limit of a function is a branch of calculus that deals with the derivatives of the function. It is the rate of change of function as the point in the domain range. So generally this logarithmic function, wherever we have a variables, to calculate that we are applying a limit. So today what we have studied: concept and definition of a limit and example, limit of a algebraic function and example. Then we have studied trigonometric function and example. Then we have studied exponential and logarithmic functions and its examples. Thanks for watching. Please like, share and subscribe for the more videos.